Hello, this is Mike at Gamefromscratch. Welcome back to our ongoing Godot tutorial series. Today's lesson we're going to be taking a look at playing streams and samples in Godot. To translate that back into normal English, you can more or less think of a stream as music and a sample as sound effects. It's a little bit different than that. We'll cover the differences shortly, but those are the basics in your mind. So we're going to be looking at playing sound effects and music. Sound effects a lot of times are things that you things like the ding when Mario jumps into power up, or the sound when your gun makes when it shoots. A lot of times they'll be concurrent. You need them to play instantaneously. So the big thing with those then, when they're called samples in Godot parlance, but a sample is memory resident. It's uncompressed and loaded into memory. This means it's quick to load. It takes up some resources, but they're faster to play, less intensive to play, but they do take up more memory. On the other hand, streamed is your longer form sound effects. Basically, it's your soundtrack. You can think of it as MP3 file type things, the sounds or the music that will play in the background as you go. They're generally stored on disk in a compressed form, so they're more CPU intensive to use, but they take up a lot less space. Since they're compressed, they're not as fast to retrieve. They're not something that's appropriate for real-time playback. You probably could play them real-time, but it's not a really efficient way to do things. But your sound effect or your music playing in the background generally isn't that real-time intensive. So that's the trade-off between the two. So just in your mind, think of a sample as a sound effect stored in memory, generally uncompressed, although there's an option to keep it compressed. So it is processor inintensive but memory intensive, and you can do multiple of them instances at the same time. On the other hand, then you've got your streams, which are stored on disk in a compressed form, and generally this is where your music is stored. Let's look at the two. They're very simple to use in Godot. However, you do have a bit of a multi-step process you've got to jump through. First off, we're actually going to need a couple of files. The cross-platform nature of Godot kind of dictates that you use two formats. For samples, it actually imports WAV file, WAV, which is more or less a raw waveform format. Each bit within the waveform is actually replicating the waveform that the sound wave makes, so there's no compression going on by default. And you can have up to 2 channels, so stereo sound, up to 44.1 kilohertz, which is the amount of fidelity in the waveform, or in more normal English, how good this thing sounds. But with Godot, you actually import the sample in, and it does whatever conversion you need. So you probably want to keep your waveforms. If you're recording or making wave files for your game, at your end, you probably want to record them as high a detail as possible, and then do the conversion into Godot, which we'll cover in a second. The streaming files, however, generally you want to store them either in Vorbis format, which is an open source alternative to MP3. MP3 itself, probably the most common format for music encoding, is also patent encumbered. So it's something you should probably want to stay away from. Technically, if your game makes a lot of money, you have to pay the MP3 board royalties for it. So a lot of people are actually staying away from MP3 format now. Unfortunately, certain hardware, especially in the Apple world, really wants to use MP3. So from the Godot side of things, at least according to their documentation, the two formats to use for encoding your streaming audio or your long form, your songs and such, are OGG, so OGG Vorbis, or MPC. Now, if you don't have your files in those formats, no problem at all. There's actually a program that you should get to know, and it's called Audacity. I don't know if I've already talked about this or not. This is a completely free format, completely free program that allows you to edit your waveforms and transfer between any file format you want. So don't get overly hung up on what format you're working in. You can use Audacity to easily convert them. But what you want is your sound effect to follow along here. For your samples, you're going to want wave files, and for your sound effects, you're going to want OGG or MPC. Now, what I often use to get them is a sound here called freesound.org. A site here called freesound.org. It's a free sign up, but then you can basically download probably thousands, maybe tens of thousands, or even hundreds of thousands of different song samples, or sound samples, or even songs that people have done. we're going to need an OGG format song. You come in here, you can press play and sample whatever it is.
On a tropical island.
Alright, that one's bad. Come on. Alright, actually, I don't even care. So we'll just go in here, we'll grab, oops. I'll download one of these as song 1. Come on. Come on. There we go. And let's grab a different one. This one. Song 2. Very popular songs here. Okay, so I've got a pair of songs here. If I go into my, as always, download folder, I already got a song 2. Okay, so I'll just go ahead and rename this one, assuming it plays. Just a sec. There we go. And we'll call that one song 1. Now, with your songs or your streamed audio, you actually just copy it into your file, into your file hierarchy. So, like so, and sound demo 2. You just drop them in like that. Now, for your waveforms, which we're actually going to cover off first, they need to be imported. So now let's just get a couple of sound effects here. Firearm reloading. Sounds good to me. And let's just grab something else random. Cannon. That's, oh, not WMV. Just a second. That was a wave I got, right? Okay, gunshot. Let's hope it's good. Alright, so I got 2 waveforms. I think I actually only need 1, but back to my download. Oh, here, I'll use this one from before. So, I got siren and let's go with shot.wave. Alright, so now that we have our sound effects to work with, obviously you can get your files from wherever you want, but you just need to be in the WAV format or OGG format. And once again, freesound.org is a very good resource for that, as you just saw. So, you have your sound effect, you want to go ahead and play them. In your 2D scene, all you do is actually go ahead and create something called a sample player. You'll notice there's actually 3 of them. There's the SamplePlayer 2D, which has 2D positioning information attached. You can actually physically put it. You see here it inherits from Node 2D. That means it has positional information. It can be dropped in your 2D world. And then you can have left-right stereo effects being done with it. Spatial here is a 3D player, so you can actually drop it in a 3D physical world. But we're actually just going to go ahead with standard plain Jane sample player. So just come on in here, create a node of sample player. Obviously, you normally wouldn't do it as your root node, but this is a demo, so obviously I'm just illustrating it that way. So we've added it in. There's no graphic attached because it's not inherited from node, so it's not a visible, placeable item, which is just fine. So now we have a sample player. We need to go ahead and create a sample library. This is a step that's a little bit different from other game engines if you worked in the past. You more or less, you bring in all your sound effect files into sample libraries and start playing from there. To create one, you just select your sample player that you created over here and go into your inspector down here and see where it says samples. You just drop this down and say create a new sample library. All right, now that you got that, go ahead and then edit it. This brings you into the editor view for your sample library. Now there's a bit of a catch here that you should be aware of right away. You can't get out of here. A bit of a UI overlook. Hopefully it's something that they'll fix in an upcoming version, but you'll notice as I switch between things, it doesn't do anything. So if you actually want to get out of here, you just go back to, and then pick a node, and you're back in your world. All right. So once you're in the editor mode for sample library, there's not an easy way to jump out of it, which is a little strange. But anyway, so here is where you edit your samples. Here's where you bring them in, import them, etc. And I'm just going to go up here to import, and we're going to import an audio sample. And you just find the file in your drive hierarchy. It doesn't need to be directly in your folder. So we'll just go ahead with, no, it's not Windows, it's downloads. So users, me, downloads, and we want shot and siren. You can control click to multiple select and go ahead with open. You know what? That might be a very bad idea. I'm just going to do a single select for now. do him. Okay, so then once you've actually picked a sound effect like so, then you've got a number of options you can set down here. From the top, basically, you can do 8-bit encoding. By default, it'll be 16-bit, so you'll have your size, but you also will more than have your fidelity. Ditto for mono. If you do not need a stereo sound effect, if there's no left and right channel, if it's just like a gunshot that doesn't pan, you might as well make it mono because you're doubling up the size for no gain at all. So mono is one channel as opposed to stereo. So again, if you don't have any positional information in your sound, if it doesn't pan left or right, if there's no variance, click this, you'll have your size. This is controlling the actual fidelity that it's recorded at. 44.1 kilohertz is the same quality as a CD. CDs are recorded at. You can do some editing here. You can make the sound loop over and over again. You can trim it down a bit. Plus, you can, like I said, you can have them compressed. Don't. So there, you go ahead, you import it, and the last thing you do is you just pick where you want it to go. We'll put it in the root. You could create a folder for your sound effects or whatever, but just go ahead, choose that. Okay, so we just imported the shot WAV file. I accidentally opened this up. I don't know how. All right, so that was just imported. If you come over here, you look in your file system, you'll now see you now have an SMP file. This is a sample file that Godot was actually generated from that wave we just passed in. And now, well, back in your audio library right here, we'll just go here and go open, and we'll add it. So here you go. You can see we now have a sound effect in our library. It's called shot, and that was taken from the file name. And this name is very important, and it's also case sensitive. So when you're bringing in your file, that is actually what determines this. And I'm not sure if you can actually, oh yeah, you can edit it. Okay, so this name right here is important and is case sensitive. All right, so let's move on a little bit. So now that we have our sample player over here, let's go back down to the inspector. You can see we've set the samples in it. There's a number of things you can set for audio specific. We're not going to do really any of these things right now, but what we are going to do is go ahead and attach a script to this guy. We'll put it in the root. Like so, and create. And I'm going to show you how to go ahead and play an audio effect. Very simple. Ready. All you do is call play and pass in the case sensitive sound effect name. All right, so we will save that. So save the scene and configure it as our run scene. This should all be familiar by now. Open, close. Now let's go ahead and run and pop. There you go. So that is how you play an audio file. Very, very simple. Now, what you're going to often run into, though, is wanting to play it from somewhere you aren't. Like, we just played it in terms of inside of the audio player itself. That's not going to happen very often. What you're normally going to do is call the sample player from other code. Let's do a quick demo of that. I don't know if I've covered UI components at all. If I haven't, I apologize, and I'm actually going to cover this a little bit more in the future, so I'm not going to go into much detail what I'm doing, but I'm going to be adding a button to the world, and we're going to then play our sound when you press the button. The details of how this is working, the details of how this is working, don't get overly plussed on them. Why are you not working? Okay, button, create. There we go. All right, so there's our button. Play sound. All right. What's that stupid? Press enter to commit. Play sound. Enter. All right, there we go. So now what we want to do is actually play the sound on this button press. So let's add a script to our button over here. My button. So, all right, and head back to our scene. Select our button, and we want to connect it. So once again, I will cover this, the UI components in a little bit more detail later on. I think I've already gone through a little bit of this, but if this is completely Greek to you, don't worry, we will look at this in a little bit more detail later on. So here's the function that's going to be called when that button is pressed. And now, when you actually want to call a node from elsewhere, like if you want to call the sample player from somewhere else in your code, well, you'll notice the sample player was created off the root of our tree or our scene graph. So all we need to do is do get tree. So that will basically be the root. Well, technically, that will be the root. And now we've just got to get the node and get it by name, and we called it sample player, as you can see here. And then now, like so. Okay, so when you press the button, you're going to get the very top of our scene tree, get the root node, find the node named sample player, and then we now have a handle to our sample player, which we just call play, for the sound effect named shot. Once again, shot is the case-sensitive name of the particular sound effect within our sound library. And we run this. Oh yeah, still calling it on load. And each time we press our button, our sound effect plays. Alright, I'll stop playing now. Now, one thing you probably didn't hear from that sound effect is the fact that each time I pressed the button there, it was starting it again. And that's because we're actually doing it as unique sound. So each time you play a unique sound, it literally, if it's already playing, starts it again. Now, there is something, you can play multiple. So a lot of times you'll have, say, 7 or 8 concurrent gunshots. You want to have the sound effects all play independently. You don't want the sound effect to start over. You want to play them in parallel. In Godot, this comes back to something called voices. And you see right here, basically, you can think of voices as channels or concurrent sounds. And let's go ahead and jack that up to 4, like so. So now we can play up to 4 sound effects at the same time. There is a little bit more work to be done. Now, the catch is that sound effect for the gunshot is way too short. So let's go back into our library and add another one. Let me import. And I want siren this time. And everything else is fine. Alright, why did you not? Okay, that's what we want. Okay, now bring that in. Alright, so again, now I have another sound effect called siren. And see, look at the waveform here in the preview. You notice how they're identical? So this one, they're a little bit different. Each channel is actually doing something different. In this one, they are the exact same wave for both channels. This is one of those cases where I should have made it mono, and my file size would actually be halved. Your other values here are your decibel and your, oh, come on, brain, work. Oh, P scale is pitch, playback speed, more or less. So if you want to do it all Mickey Mouse, you can increase this up. If you want to slow it down, you can turn this down. But you can see a sample of your waveform right here, and you can actually play it right there. And you can stop playing it up here, and you can delete it using this. So that's how you add another sound effect. So we've added siren, which, as you heard, goes on much longer. Now let's head on back to our code here. All right, so switch this up to siren, like so. And we just want to add one more parameter here. If we go here, the second value is unique. And what you're saying is, yes, this is a unique instance. So when I call it again, it is going to play another one until I have up to 4 playing. So now when I go ahead and play this, all right, each time I press the button, it will start a siren. So I'm going to have multiple sirens going at the same time, up to 4. All right. Am I backwards in my logic? There you go. Sorry, my logic was incredibly reversed. That true value is actually saying it's unique. So the value is unique. So if you say yes, it means it's a unique instance of that sound, so that every play should be the same version. So by saying false, you're saying nope, create a new one. So sorry, my logic on there was reversed. But that is what you got to do if you want to play multiple at the same time. All you do is pass in false for that second parameter there. Now what you've got sometimes is you're going to want to control that instance once it's playing. So you have your sound effect itself, which is stored in our library, but each instance can actually be controlled differently. It can have a different volume and so on. And this is something you handily do with something called a voice ID. And this play call is actually returning an ID to us each time. So let's just, here, let's break this code out and make it a little bit easier to read. So var player equals, get a reference to our player, player.play, and then we'll play our siren sound like so, but it's returning a value called voice ID. So for each unique instance, we will get a voice ID back, like so. And then using that voice ID, we can now control individual values of that. So, for example, set volume, and you pass into set volume the ID to manipulate, and the amount as a value, I believe from 0 to 1. So here, let's have the volume of our siren. And play. So to illustrate that a little bit better, let's 10th the volume. There you go. So using voice ID is how you allows you to manipulate an instance of a playing sound. And that's kind of it, really. Playing sound effects is very simple. You create your sample, you import your sample into a sample library. Samples can be shared between multiple sample libraries. Sample libraries can be reused, although can't really think of why you'd want to offhand. But that's kind of it. You bring your WAV file in as a sample library. You either import it as stereo mono, and depending on your resolution, or each one adds to the amount of space taken. Keep in mind on mobile devices or HTML targeting when that comes, you're going to want to keep the file size down if you can help it. So if it doesn't need to be stereo, if it doesn't need to be 44.1 kilohertz, that's a way to really optimize some space there. So consider when you're doing your import to set those values down. You saw it was part of the import sample process. So when you're encoding or recording or whatever, you're do it as high a fidelity as you could ever want, and then let Godot take care of the resizing for you if you wish. Now, let's take a look at music. Music's actually incredibly simple. As you saw earlier, we just dropped a couple of files into our file system. Okay, they've not been imported. They definitely should be there. Sound demo 2. Okay, so we have song 1 and song 2. There they are. All right, so song 1 and song 2.ogg. So we just want to go ahead and play them. The process is almost identical. Instead of the sample player, however, here let's purge a bit here. By a bit, I mean pretty much let's get rid of everything. And we'll just go in here and we will grab instead a StreamPlayer. Once again, you've got one that can exist in the 3D world or just the regular plain Jane one. We're just going to go ahead with the plain Jane one. The logic between the different players is actually not that different. There's more functionality in the 2D and spatial version, but that's pretty much the extent. So you can obviously figure that stuff out on your own, no problem. So there's our StreamPlayer added to the scene. I'm probably going to have to make a save now. All right, and okay. And now we just want to set up our stream. So let's pick our StreamPlayer, go over to Inspector here, and you'll see this value here for stream. And we just drop it down. The different player types supported, we want to just go ahead with the OGG version right here, like so. And we want to load one, and we will go with song 1, like so. And you can actually, without any code at all, you can just come in here, go autoplay, and that might be enough. Let's go ahead. There you go. So there's your song just playing. You want to loop it, you set that to true. Let's restart. Now go. And it'll play again. So no code version, literally just drop it in and off you go. However, a lot of times you're going to actually want to queue one song to play after another song after another song. Just as easy. Let's look at that process. First thing, let's go here and add a... for our StreamPlayer then, we're going to add a little bit of code here. We're going to have it so after your one song finishes, we're going to go ahead and play another one. Let me just show you how that works. Let's go back to our scene, get him set. So we don't want to loop and we don't want to autoplay anymore. So we've got song 1 set as our stream. You can only set one stream at a time. However, you can quite easily load and change them on your own. And let's show you that. So in the code behind for our StreamPlayer here, let's create song 1, song 2, and Current song is currently set to song 1. Okay, now let's get rid of all this, and we will put this in our process. So we need to tell it we want a process, and next up, we're going to go ahead and load song 2. Loading things yourself is super simple in Godot. So song 2 equals, guess how you do it? You call load. Yeah, that's it. So loading files in Godot, very, very simple, and that will return an instance of a song for us. So now let's implement our process. And all we want to do here is check if our current song is done playing. If it is, swap it. Very simple logic. So self.isPlaying. So is any song playing? Oh, sorry. If there's no song playing. So we want to detect that the playing is done as opposed to currently playing. So first we're checking, are we currently not playing any songs? So it means we've stopped playing. If that's the case, we will go and get the stream, which is the value we set over here. And that's just got via get stream, like so. And we check to see if it is song 1. If it is, we will go self.setStream and set it to song 2, like so. Otherwise, we set it to song 1, like so. And finally, we play. Now, once again, I am actually in the StreamPlayer doing this code, which is why I'm getting away with the self.calling. You can get the StreamPlayer as a node just like we did with the SamplePlayer. So you could call this, what I think is quite common to do is to put a StreamPlayer and a StreamPlayer and a SamplePlayer in near the root of your scene hierarchy and call it wherever you need it. As opposed to calling it itself like this. But you can do it either way. And as you see, this one will now go ahead. It'll give me an error because I forgot a semicolon. There's song 1 over. Alright. Maybe I should... song 1, set it to song 2, set it to song 1. Loading song 2. Over here I am loading song. I obviously have a logic error here. Loading song 1. Let me just check to see what. Let me see what each one of these things is. Alright, song 1. Song 2. Ah! My bad. Where you don't ever actually play song 1. So ends, use song 2. Song 2 ends. Why is song 2 ending and queuing song? If get stream equals song 1, set stream to song 2. You are never returning song 1. I am never defining song 1. Alright, that's a bit of an oversight. Song 1 equals self.get stream. Alright, song 1 never actually had any meaning. Song 1 finishes playing, song 2 goes. Song 2 finishes playing, song 1 goes. Song 1 finishes playing, and back. And this will go on literally forever. Sorry, bit of a mistake on my end. So quickly go through the code right here. Obviously, I'm setting it so we have a per frame update. I load the second song using the load function of Godot. The first one we already loaded via the inspector right here, so I simply get a reference to it, and I start off playing. This also could be achieved using autoplay right here, but here I'm doing it in code instead. So then each frame we check to see if we are currently not playing a song. So in other words, the song that was playing is done, and in the case it is done, we flip between our two songs. It helps to actually define what both songs are, otherwise it will always evaluate to the else condition, which is what was happening there. And then finally, once we've swapped our strong, I can't speak. Once we've swapped our songs to be playing, we can then start the StreamPlayer off playing again. So basically, that's the extent of it. The playing sound effects and music in Godot is very, very, very straightforward. You basically either use a StreamPlayer or a SamplePlayer, add it somewhere in your scene graph. You can call it to auto-load using the inspector to change it. When bringing your samples in, samples are uncompressed WAV files, which then you can either compress them, which will have a performance hit, but will make your file sizes a bit smaller. So if you have a very, very large, which you probably shouldn't, but if you have a very large sound sample you're playing a lot, it might make sense to compress it, but it probably makes more sense to not make it so large, to be honest. Whereas your StreamPlayer, your stuff, your music, your background stuff, is stored on disk. You literally just copy it into your folder hierarchy, and then you use a StreamPlayer to play it. As you saw from where we very first started, you don't need to use code at all. You could literally just set it as the StreamPlayer, set the stream, set it to autoplay and loop, and then you've got infinite music playing with no code at all. On top of what we all looked at right here, there's actually some more advanced versions of each one. There's also a StreamPlayer Spatial, as well as a SamplePlayer 2D and a SamplePlayer Spatial. The biggest difference is those ones have positional information and can mimic some positional panning in your headset itself. So they allow themselves to be placed in a world, spatial being 3D, 2D being 2D, but for the most part they work exactly the same otherwise. So you create your library for the sample players, you add all your files to it, and that's about it. Hope that was useful. I hope you enjoyed that. Thank you very much. Goodbye.